Welcome to Homework Lib.
Hi, so in this problem we have added 0.5 grams of HF pure into a 2-liter flask. So we need to know the concentration of HF, and in order to do that we require the amount of mole. In order to get it, we simply divide 0.5 grams divided by the molar mass. In this case, this is 20 grams per mole for HF. And the result of that, we're going to divide it by 2 liters. The concentration of HF that we have at the very beginning, it is going to be 0.0125 molar. So this is going to be our initial concentration. Now, we're going to look at the reaction H2 in gas phase plus F2 in gas phase. This is going to produce two equivalents of HF in gas phase. And we are told that the Kc is equal to 2.35 times 10 to the 3 at 298 Kelvin. Okay, but now what I want to do is look at the inverse reaction and see what is going to happen. So the inverse reaction would be two equivalents of HF in gas phase are going to produce H2 gas plus F2 in gas. Now, what would be the equilibrium constant for this? I'm going to call this Kc2, and this is going to be equal to 1 over Kc. So 1 over 2.35 times 10 to the 3 would be 4.255 times 10 to the 4. To the minus 4, sorry. Okay, so now we got this new equilibrium constant. We are going to proceed with our ice table. We have an initial concentration. This is the value. I'm going to call it C0 just for sake of simplicity. And what this is going to happen is that the amount that is going to react to produce H2 and F2, it is going to be a minus 2x. This portion corresponds to generating X and X of each of the gases. With this, at equilibrium, we're going to get C0 minus 2x, X, and X. Nice thing. So, the next step in our procedure is this equilibrium constant 2, which value we have already calculated. It is going to be equal to, in theory, would be concentrations, but we can also do it with pressures. But let's go ahead with concentration of H2 times concentration of F2 divided by concentration of HF squared. This is giving us, replacing the values that we found at equilibrium, xx, c0 minus 2x squared. This is x squared divided by c0 minus 2x squared. Now, what we are going to do is take the square root on both sides of the equation. So, square root of kc2, it's going to be equal to x divided by c0 minus 2x. We continue the procedure and solve for x. This now becomes square root of kc2 times c0 minus 2 times the square root of kc2 times x is equal to x. Putting the x's together on the same side, this becomes x times 1 plus 2 times the square root of kc2. Factorizing, I transfer this to the right hand side and factorize. This is going to be equal to a square root of kc2. Finally, the value for x is going to be equal to square root Kc2 divided by 1 plus 2 times the square root of Kc2. Replacing the values, Kc2 was this number, the square root of Kc2 is 0.02063. So this equation becomes 0.02063 divided by 1 plus 2 times 0.02063. Okay, so the result is finally 0.0198. Amazing. So this is the value for x, and this would be actually the concentration of H2 and the concentration of F2 that I'm going to find at equilibrium. But we're asked about the concentration of HF, and the only thing that we need to do is do C0 minus 2x. Concentration of HF is equal to C0 minus 2 times x. My initial concentration, we said that was 0.0125. Wait a second, here just a little bit of a correction because I realized that I forgot here to add C0, so let's forget about these values. And the value for x is going to change a little bit, okay? And the only thing that is going to change is that essentially I forgot to multiply this by C0 from this section over here. So this is C0 times that square root. So everything now should be correct. And the result for this is that x will be equal to 2.5 times 10 to the minus 4, rounding up. And now that is going to be the concentration of H2 and of F2. Now everything matches up correctly. And now for C0, remember that this was 0.0125 minus 2 times x. So 2 times 2.5 times 10 to the minus 4, which is 5 times 10 to the minus 4. 5 times 10 to the minus 4. Okay, and the result is 0.012 molar. And now this would be the correct answer. Okay, so sorry about the confusion over there. I just forgot here to add the C0, but if you follow the algebra, you're going to see that the result matches up correctly. And we have the concentrations of all of the species at equilibrium. So these are the equilibrium concentration of HF, and these are the equilibrium concentrations of H2 and F2. And that would be all. Thank you very much.